Yeah. Yeah. Good afternoon. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment, right? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Fine. Thank you. Yes. So as part of today's topics, what is big data? Why Hadoop? Drawbacks with the current databases. Drawbacks with the current databases. Hadoop advantages. Hadoop and Spark advantages. So now first I'll talk with Hadoop, later I'll come back to Spark. Hadoop advantages. Hadoop. Hadoop and Spark job market. So starting with what is big data? So big data, the name itself saying like huge volumes of data. Yes. Currently the data is stored in the form of data storage units, KBs of data, MBs of data, GBs, gigabytes, terabytes, petabytes, exabytes, zettabytes, etabytes, sotabytes, so on, right? Yes. So you should have KBs, MBs, GBs, or even TBs of data. But petabytes of data, is it getting generated in the current real world? Examples of petabytes of data generation, right? 1 petabyte equal to 1024 TBs. 1 petabyte equal to 1024 TBs. Already 1 TB is a storage unit, right? So if we take example of sector like SBI or HDFC, right? So within the city, it's a bank like SBI. Within the entire state, we see thousands of branches. Within the entire state, with entire country, we see lakhs of branches for SBI. Again, in each branch, we see millions of customers making multiple transactions per hour, per day, per week, per month, right? Each and every transaction has to be stored. So huge data is getting generated, right? And forget about this. You are aware of the social media like Facebook, right? Facebook has got users not only within the country, it has got users throughout the world. Millions and trillions of users for Facebook. Yeah. In a minute, how many posts and videos are getting circulated? Each and every post has to be stored, right? What is the data generated by Facebook in a minute? And what should be the storage capacity for storing all those? Not only like Facebook, right? Today we have got many applications which are generating huge data in petabytes. Talk like just a 1 minute transaction. Just take 1 minute transaction in a 1 minute. How many Facebook posts, Twitter tweets, Google queries in a minute? Everyone are querying in the Google and YouTube videos upload. What should be the storage capacity for storing all the videos? And millions and trillions of people using email or Gmail, right? Storing all the messages, huge data, right? And even just now I was talking about the bank transactions, lakhs of branches, millions of customers making multiple transactions, right? Not only bank transactions, telecom transactions, and e-commerce transactions like Flipkart or Amazon, right? Everywhere we see like huge data is getting generated. Today, like all the applications, most of the applications are generating petabytes of data. Google generating more than 500 petabytes per month on an average, right? And all the other applications like YouTube, Twitter, all this Facebook generating nearly 400 petabytes per month on an average, right? So currently we have got databases. Currently we have got databases, right? Databases can handle up to some extent. Like we have got a databases like Oracle, MySQL, Oracle, DB2, SQL Server, right? All this they are used for OLTP, online transactional processing for day-to-day operation. But specialized databases. What specialized databases? One second. Yes, we have what are specialized databases. Specialized databases like Teradata, yes, Netija, Vertica. These specialized databases, they are used for data warehouse purposes, right? DWH, for data warehouse purposes, for OLAP operations, for online analytical processing, right? Yes. So these databases are specialized databases. They can handle data up to some extent there. Like databases of GBs of data, specialized databases can handle terabytes of data, but beyond that, they cannot handle data. So as a solution to all these storage level problems and processing level problems, right, we have got a framework called Hadoop. So before I go with the services of Hadoop, right? Yes. You need to know how the data is getting generated, right? Assume this is the data which got generated from the last 50 years. This is your data which got generated from the last 50 years, from 1974 to 2024. If you observe the data, 1974 to 2014, previous 40 years of data, and this last 10 years of data. Nearly whatever 80% of the data what we are seeing, right, has been generated from the last 10 years, and only 20% of the data has been generated from the previous 40 years. Reasons for huge data generation, especially from the last 10 to 15 years, usage of technology, usage of internet has increased a lot, and usage of smartphones. Okay. And from where this data has been generated, from where this data has been, mainly we can see three sources of data, right? It's mainly three sources of data. Social data, machine data, and a transactional data. Data is being generated from social data. That is, we have got three sources: social data, machine data, and transactional data, right? Social data means data which got generated from the social websites like WhatsApp, Facebook, Twitter, all this, right? And machine data means data which got generated from reading the barcodes or the scanners by reading the RFID chips, right? Such kind of data we call it like machine data, right? Transactional data, data which got generated from day-to-day transactions like bank transactions, telecom transactions, right? Such kind of data we call it as like transactional data. Yes. So mainly three sources of data, and the data is going to occupy three formats, three types, right? Three types of data. Three types of data, mainly structured, structured data, semi-structured, structured, semi-structured, and unstructured. Structured data, semi-structured data, and unstructured data. Structured data which got generated from DB tables, data which is in the form of structured form, like the form of rows and columns from database tables, Excel files. Semi-structured data which is not fully structured, which is not fully unstructured, like XML files, JSON files, right? Unstructured data like short messages, articles, images, videos, all this, right? So the biggest challenge today, like most of the data is going to occupy in the form of unstructured format. The data which is generated today is mostly taking unstructured format, but databases can handle only structured data. So Hadoop is a framework which can handle all varieties of data, structured, semi-structured, and unstructured, right? Yes. So as a solution to all constant processing level problems, and as data is increasing enormously, so we have got a framework like Hadoop. It's meant for two things. It's meant for two things, right? Yes. For storage and for processing. It is meant for both storage and processing. Generally, if you see any technology either meant for storage or meant for processing. We talk about C or C++ or Java, right? .NET, all these they are meant for processing. Like you talk like Oracle, MySQL, DB2, SQL Server, all this meant for storage. Either they're meant for storage or meant for processing, but Hadoop is meant for both storage and processing. For storage, does Hadoop use any database for storing its data? No, it uses a special kind of file system called as Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce or Spark. So Hadoop is meant for both storage and for processing. For storage, it has got HDFS. For processing, MapReduce or Spark. Okay. And coming to this, why databases are not used for storing this Hadoop's data? Drawbacks with the current databases. Drawbacks. Drawbacks with the current databases. First thing is limited storage in most of the databases. Limited storage, right? Like unlimited data storage is not possible. Limited storage in GBs or in TBs. Secondly, no parallel processing in most of the databases. No parallel processing. Thirdly, if volume increases, right? Speed decreases. Example, right? If we take any query like select total amount, sum of amount, right? Total amount from, select total amount from sales 1. Select total amount from sales 2. Sales 2. Select total amount from sales 3. Three different tables. Three different, I want the total amount, right? Total revenue generated, right? Yes, total amount from sales 3. Sales 1, sales 2, and sales 3. Sales 1 has got 10 records. Sales 1 has got 10 records. Sales 2 has got 1 lakh records. Sales 3 has got 1 crore records. Okay. Total amount from sales 1, 10 records. Total amount from sales 2, 1 lakh records. Total amount from sales 3, 1 crore records. So which query is going to execute faster among these three? Total amount from 10 records, or total amount of 1 lakh, or total amount from 1 crore. First query is going to execute faster, right, as compared with the other. Right. So query to query, as the volume increasing, speed decreasing, right? And one more, like if volume increases, if volume increases, sorry, if complexity increases, if complexity increases, speed decreases. So to justify this, what if complexity increases means if I take the total amount from sales 1, select total amount, select total average amount, right? Average amount from sales 1. Same table. Total amount from sales 1, average amount from sales 1, standard deviation of amount, right? Select the standard deviation of amount from sales 1. Yes. So if you have got, so if this total amount from sales 1, if it has got 1 lakh records, average amount from sales 1 also 1 lakh records, standard deviation of amount from sales 1 also if it has got 1 lakh records, right? So from query to query, complexity increasing, if complexity increases, right? Speed decreases. If query to query, if complexity increasing, speed decreases, right? Yes, speed decreases. Yes, speed decreases. So because the average amount is a two-step process. First sum to be calculated as average to be calculated as compared to the first query. Second query takes more time. Standard deviation takes a lot of internal processing that as compared to this. And the major drawback with databases can handle only structured data. They can handle databases can handle only structured data. They can handle only structured data. They cannot unstructured or semi-structured kind of data, right? Yes. For example, if I'm taking, for example, if I'm taking reviews for a particular movie, if I want to take reviews for a particular movie, right? Yes. User and review. User and review, right? Yes. User 1, user 2, user 3, user 4, user 100, right? 100 users. First person saying the movie is good, second person saying the movie is bad, third person saying movie good. They're giving feedback in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros, right? Yes. Single grouping and single aggregation, right? Select review wise, I want to count, review wise count, I want to count star from reviews table, group by review. Select review wise count from reviews table, group by review. Review wise count star from reviews cube by review, right? Or review 1, 0. Form of zeros and ones, right? Like 90 people, they're saying the movie is good, 10 people saying the movie is bad, right? Means review wise count group by reviews, right? So for this kind, okay, but generally reviews won't be given in the form of ones and zeros, right? For example, first person saying movie is good, second person saying movie is not good. In this way, right? Can you write an SQL query to count the number of goods and not goods, right? Here, not possible. Or even if you use, if you just count by using this keyword good, right? It gives wrong computation because even not good has got good in it. So they cannot handle this kind of data. Which one? Databases, right? The major drawback is databases can handle only structured data. They cannot handle unstructured or semi-structured data, right? Yes. Now, advantages. Hadoop advantages, right? Yes. Hadoop advantages. Unlimited data storage. First thing is unlimited data series, unlimited data storage. Unlimited data storage. Second thing is Hadoop advantages, unlimited data storage, very high speed processing, very high speed processing, unlimited data storage, very high speed processing, can handle all varieties of data, can handle all varieties of data. And it is an open source. No licensing is required, right? That's what commodity hardware. Commodity hardware, very highly configured systems are commodity hardware. See, main advantages, right? Unlimited data storage, right? Unlimited data storage, very high speed processing, very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured, open source, right? Open source. No licensing is required and a commodity hardware. Yes. Okay. Now, Yahoo has conducted a test. Yahoo has conducted a test to check the speed of different databases, right? It has taken a table of 100 TB, right? Consisting of 1024 columns. 1024 columns, right? Yes. What is the task? Task, right? Yes. Sorting based on 16 columns. Sorting based on 16 columns. That is the task. and time taken, right? Time taken by different databases. Time taken by different databases, right? Like Oracle has taken nearly 3.5 days to process it. MySQL has taken nearly 6 days to process it. 6 days. Okay. Oracle has taken 3.5 days. MySQL has taken nearly 6 days. And Teradata, right? Teradata is specialized data warehouse used for data warehouse. That's just taken 4.5 hours. Another specialized database like see, we have got specialized databases, I said, right? Teradata, Netija, Vertica. So these databases, Teradata has taken 4.5, Netija has just taken 3 hours. That's just taken 3 hours. And finally, Hadoop has taken, right? Hadoop has just taken 3.4 minutes to process it. That is the speed of Hadoop as compared with the other databases. The latest version of Hadoop has taken just 1.2 minutes. Yes, that is what the speed of Hadoop as compared with the where they have taken days of time, hours of time, but Hadoop has taken minutes of time, right? Yes, right. So Hadoop is proven in the market, storage point of view and processing point of view, right? So most of these like ETL kinds of projects are getting migrated to this Hadoop and Spark environment. Yes, where it can process it in a very fast time, right? And for huge data storage and for huge data processing, right? This Hadoop and Spark, but Spark it has got very high speed as compared to this all these technologies, right? Spark has got very high speed because of in-memory computation, right? I'll just give introduction to that Spark also, right? Just I'll give some knowledge on this Spark. Okay. So PySpark, right? Yes. What is PySpark? What is Apache Spark? Why PySpark? Why PySpark required? Need for PySpark. Need for PySpark. Real life usage, right? Real life usage of PySpark. PySpark job market, right? PySpark job market. Yes. What is Apache Spark? Why PySpark? Need for PySpark. Real life usage of PySpark. PySpark job market, right? Yes. So what is Apache Spark? It is an open source distributed cluster computing framework introduced by Apache Software Foundation. So I can say it is a general engine for data big analysis, for processing, and for computation, right? Yes. So why PySpark required? It is a Python API. It's a Python API. PySpark is a Python API to use Spark. So I said it is used for big data solution. It is the lightning fast technology that is designed for fast computation. One of the demanding tool among the data engineers to work with bigger data sets, right? So it is mostly used, PySpark is used for running for creating data pipeline, for ingesting data into databases. PySpark is used for running machine learning algorithms, working with graphs and data streams, for running distributed SQL, right? Yes, we have got Spark SQL concept available, right? So need for PySpark, right? For example, large amount of data is generated. So the data contains huge that is hidden. So we require sufficient tool to perform these different types of operations on this big data, right? Yes. So there are various tools already available in the market, right? But these are not that much appealing, right? So we need some scalable and flexible tools for cracking this big data and gain benefit. So PySpark is such, right? Combining Python and Spark. Python and Spark, right? It will be the very efficient for the world of big data, right? Yes. That's why Apache Spark community came up with a tool called is that tool called PySpark. There's Python API for using Apache Spark. Okay. So real life usage of Python, right? Real life usage where mostly it is used, right? So in commercial sector, right? It uses Apache Spark for real-time processing. Banks and other financial systems using Spark to retrieve the customer social media information and to gain useful insights, can help in taking right decisions, in credit risk assessments. Also, it plays a important role in fraud detection, in healthcare, to just analyze the patient's records along with the previous medical history, and also just predicting which patient is mostly going to face that issue even after being discharged from the clinic. And for entertainment industry, right? Like PySpark is used in the entertainment industry, right? So total this entertainment or these movies, they are totally moving towards this online streaming. So one of the best online streaming, online entertainment platform, Netflix, uses the PySpark for real-time processing, right? For online movies or web series. So it processes nearly 450 billion events per day over server-side applications, right? Yes, for even the entertainment industry. And even in e-commerce and in trades, right? Like Flipkart, Amazon, all this, they use the Spark for advertisements. So like for enhanced customer experience, optimizes the overall performance, right? And for tourism, even for tourism industry also, right? So giving advices to millions of travelers by comparing hundreds of tourism websites. So PySpark job market, right? Very high speed processing as compared with the other technologies also, right? Spark, Spark has got very high speed even as compared to Hadoop also, right? So Hadoop has checked 3.4 minutes, takes an hours. But if you talk about the Spark speed, right? Spark, the speed of PySpark, Spark 100 times faster. Spark 100 times faster than this. 100 times faster. See the speed of Spark, right? That's why the name Spark. So Spark combined with Python, yes, it's an efficient tool for the world of big data, right? See the course content, what I'm going to discuss as part of, if you talk about a very brief introduction to this big data, Hadoop, need for Hadoop, sources, types, languages, storage, Hadoop ecosystem components, HDFS, Hadoop distributed file system. You need to have the knowledge about this HDFS file system. You need to know the HDFS architecture, the storage architecture and processing architecture, metadata management, replication, storage and processing, fault tolerance mechanism. And MapReduce is a parallel execution model, right? Which is mostly used in Hadoop. This the MapReduce is the execution model in Hadoop. So how is that mapper face, reducer face, all this? And scoop for importing or exporting operations. For importing data from databases to Hadoop and for exporting data from Hadoop to databases. Import and export operations. During this import operations, we can perform different operations like transformations, filtering, grouping, sorting, merging, all this, right? Before data is coming to Hadoop environment, right? Yes. Scoop, the name of the full SQL plus Hadoop, the first two characters of SQL, last three characters of forms scoop. Yarn, yet another resource negotiator, right? Yet another resource negotiator. In the previous version, there were some drawbacks, and but all those drawbacks are rectified from the Hadoop 2 version onwards, right? Or we have got many architectural changes. So what is the yarn processing, yarn components, how it is going to be processed, what are stored at the master level, what are stored at the slave level, everything I'll be discussing. NoSQL databases. Okay. So what is NoSQL databases, types of NoSQL, and one NoSQL database like HBase I'll be discussing as part of this. And also I'll be giving knowledge on streaming data and technologies like Flume and Kafka. Streaming data means data which keeps on generating, data which keeps on incrementing. Such data we call it as streaming data. HBase. So HBase is one of the NoSQL database that I am going to discuss. And the important component of Hadoop, right? Hive, Apache Hive, right? So it's a data warehouse kind of environment, right? It is a data warehouse kind of environment in Python framework. So Hive architecture, Hive query language, just like SQL, we have got HQL language. Yes, difference between HQL and SQL. SQL can process only structured, but HQL can process this semi-structured kind of data, like even XML data, JSON data, URL web logs data, everything will be processed. And different types of tables, internal tables, external tables, difference between both internal and external, and UDF, user-defined functions, user-defined aggregate functions, user-defined tabular functions, right? Non-partition table, non-partition, multi-column partitioning, static partitioning, dynamic partitions, performance tuning mechanism in Hive, bucketing in Hive, indexing in Hive, Hive and HBase integrations, right? Hive and HBase integrations, right? And after that, PySpark, right? Which is in-demand technology in the market today, right? What is Apache Spark? Why PySpark? Need for PySpark, PySpark session, PySpark context, RTD parallelizing, repartitioning, broadcast variables, accumulators, RTD computation, right? Persistence options, different types of persistence, memory only, memory underscore SCR, memory disk only, disk underscore SCR, memory and disk, PySpark core computation, fault tolerance model, different ways of creating word count example, and groupings and aggregation, single groupings, multi groupings, single aggregation, various inbuilt actions and transformations, right? Of PySpark SQL data frames, right? So the creating of data frames and creating data frames, RTD to data frame, show, struct type, struct field, select, collect with column renamed, drop, group by union, UDF map, flat map, sample, fill nut, all this, right? Aggregate functions, window functions, date and timestamp functions, JSON functions, read and writing JSON file, PySpark built-in functions, when EXPR, lit, split, concat, overlay, to timestamp, to date format, date if, months between, explode, array contains, array contains, collect list, collect map, map keys, map values, row number, rank, dense, all this, right? Different inbuilt functionalities, and PySpark external sources, Spark and Hive integration, MySQL integration, working with CSV, JSON files, transformations and actions, wide transformation and narrow transformation, adding of new columns, dropping of columns, renaming, adding of new rows, dropping of rows, handling nulls, joins, window functions, deployment must local mode, cluster mode, PySpark application, stays and tasks, drivers and executors, building Spark applications, pipelines. Yes, PySpark streaming concepts, integration with Kafka, PySpark MLlib, right. This what in brief on this PySpark and the environment. So even you will be given knowledge on Linux. So here it's a package, right? Like big data, concepts, Hadoop, PySpark. So it's a package, right? So Python, okay, this Hadoop, PySpark, and Linux in the weekends. The weekends, right? Saturday 2 hours and Sunday 2 hours, right? Yes. Saturday and Sunday, right? It takes. So like 2:30 to 4:30 on Saturday, 2:30 to 4:30 on Sunday. All right. Which goes from Monday to Friday. The fee structure for this is 15,000, right? 15K. So if anyone, if you already joined for Python, if you have already paid some fees for that, that will be deducted from this. If you already paid anything like 5,000 for Python, you can need to pay the rest fees 10,000 for. So it's like people we are getting Python all along with this, right? Yes. Any queries from side? Any queries from it? Okay, you are going to get the video of it. Each and every video you are going to get notes, clear and soft copy of the notes and tasks to work with, and a WhatsApp group will be created, right, for technical discussions. Okay.
Is it mandatory to learn Linux in order to become data engineer or Hadoop engineer?